picture, hot aisle, cold aisle. What's important to notice about this image, though, is that it's an ideal configuration. We have just the right amount of air being delivered into the cold aisle. All that air is sucked up by the IT equipment. There's no excess cold air leaving the cold aisle. We have no cold air coming out of any other openings in the raised floor. This is a perfect situation. However, airflow management is invisible. Air moves and we can't see it. So unfortunately, this is the reality of what's going on in many computer rooms. And just a few things to point out. We have air coming out of unsealed cable openings underneath the cabinets. There's some misplaced perforated supply tiles in a hot aisle or maybe out in an open space in the room. And we've got exhaust air recirculation over the tops of the cabinets or maybe around the ends of the rows. And all of these things reduce the efficiency in the room and take up capacity. And by improving these things, we can recover that stranded capacity. So let's look at how this plays out with PUE. Now, probably everyone on this call is familiar with PUE, and if you're not, we'll go through it at a high level so you have an understanding, because it's a really important concept. It's a metric that has gotten the most adoption around the world again, and it is defined as the power usage effectiveness. And there's a direct relationship between airflow management and PUE. When we look at how power is consumed in a data center, this pie chart represents all the power consumed, the total load of the entire data center. And PUE is simply taking the total load and dividing it by the IT load, the power going to the IT equipment. And for this example, we have a PUE of 2. The IT equipment represents about half the load, so the total divided by half gets you to a PUE of about 2. And when you look at how this breaks out, when you look at the power required for the mechanical cooling and the cooling fans, this represents 35% of the total load, but a whopping 73% of the non-IT load. That means that improving the efficiency of the cooling is the greatest point of leverage in reducing the operating cost, improving the PUE, and regaining stranded capacity. And you know, when you look at the other loads, such as electrical losses and lighting, you know, there may be a very good business case for improving the efficiency or replacing a UPS system, but that's affecting a relatively small portion of the pie. The greatest leverage exists in the cooling optimization, and the way to start there is by airflow management. It starts with something as simple as blanking panel use.